moment while this spins up. And that is probably that. All right, folks. Welcome, everyone. Thank you for joining us for another DevOps Toronto. This is February already, which is amazing. But we are ever closer to spring, which is the thing that is constantly on my mind. So I'm going to get through all the intro stuff pretty quick and get on to our main talk. But I do want to toss the mic to Pat for a moment because he's here and live with us, so he can introduce our post meetup hangout experiment that we've been running.
Sure. Yeah, it's kind of it's seeming a little busier and busier each week. Hopefully, even with the meetup challenges, I don't know, maybe people will still have some energy at the end. But just giving you a heads up that one of the things we lose by going online is that we can't just like hang out in the lobby or like wander somewhere after or just chill on the sidewalk. It's just done and this thing closes and then we're all kicked back to probably to sleep, which is good. But if anyone does have extra energy and wants to like meet some people who are here listening with them, then this is a sweet tool called GatherTown, and we're just hopping onto the link as soon as it's done. You can stay for 2 minutes, or you can stay for an hour. It's kind of doesn't close. So yeah. Anyway, it's a little wandering around tool where you can have smaller conversations instead of all looking directly at each other. Yeah, that's all. Maybe I'll catch after.
I love that part that it just lives continuously. That's so cool. And that's like a totally valid aspect of Slack too that I've just never acknowledged, because Slack is so like ordinary now. But the fact that it's just like a constantly running 24/7 conversation venue is just so cool. So it's a wild time to be alive, everybody. All right, so I want to thank our sponsors really quick. We are sponsored by some wonderful companies. Among them, I'm sure you recognize all of these big names because they're not small players in the space. They've been in this for a long time. CloudBees, big time DevOps, end-to-end tooling and infrastructure organization, BMC likewise, and JFrog, who've been with us the longest. JFrog, shout out to you folks. I don't know if anyone's in the audience today, but we love you guys. We love all our sponsors, but shout out to JFrog for just being at it for so long. Love that.
Well, you got Christian on the line, so I told him about this, so he's representing.
Excellent. See, they always show up too. It's so great. All right, so with that, I'm going to toss the mic to Rob. I'm going to stop sharing my screen. I'm going to give him the podium of sorts, and he's going to talk to us about open source and all kinds of automation, visibility, observability, awesomeness. And with that, and just really quick, before I do that, I want to tell everybody about next month, because I always forget. So next month, we have Caspar from Humanitech. He's going to be talking about research that they've done on internal development platforms, basically developer experience. And so tune into that. That'll be coming next month. But on to the main event. Thanks, Rob, for joining us. Really appreciate you sharing your thoughts and experience with us. And I will hand you the screen.
You're on mute. Oh, still on Rob, mute. I think still on mute.
Maybe I can pause.
All right, here we go. There we go. That would help.
There we go. There we go.
All right, there we go. So yeah, thank you very much. I'm going to just share my deck at the same time. But yeah, just this talk was about SLOs and GitOps. This is something that we've been doing So just as a way of introduction, maybe I'll start there. So yeah, so I'm Rob. I'm here in the US. My role at Dynatrace is a partner manager, but I am on the technical side. So I do get hands-on with the tools and, work with a lot of the partners. So you can see some of those actually, we were just talking about KubeCon a second ago, but a lot of those, we were out at KubeCon. We go to the major shows, we have major hyperscalers. And so that's kind of my role to intersect them, but we have a lot of fun along the way. Right in the middle is my little dog. That was yesterday. We got 1.5 feet of snow, so he was pretty happy. But yeah, so happy to share my thoughts with you guys because it's really about DevOps. So I have kind of some fun things because I made this deck for you guys this morning. So no reason I have a duck theme, but there is a duck theme to this. But really just to kind of start off, just to kind of ease our way into our day. It's as we talk about managing applications and scaling them and microservices and moving to Kubernetes, we're moving from a world that, we knew our app. And that's kind of what this little thing is supposed to be. It's kind of fun where, I know my little baby, I know everything about it. I know it's healthy because it's small, it's manageable, I can do it. And then and I'm sure you guys have talked about this in this meetup group, but really the best practices around trying to manage your little baby are around service levels. So service levels aren't anything new, but what we'll see is, how do we actually implement this concept? So we've all probably read this book, the service level indicators are the measurement, and we have objectives, and then they feed into SLOs. And usually people think about it from an operational standpoint, have a big dashboard. And so, this is kind of my video fun number 2. So, but now the idea is like, hey, when we have a bunch of these, new services here, it's really not scaling. So that's kind of the analogy I'm making is that, as we have more things flowing down our pipelines, more little ducks to manage, they have more service level indicators to keep track of. And now it's without some sort of system to do that in an automated way, it's just not effective through, paper and pencil, if you will. So I need to do something else. So that's where the talk is really, segue into the talk. So what we're doing now, and this is where we want to share ideas. So this is just one way that I'm going to talk through with our open source project. We've been developing a framework and a declarative way to define SLOs and SLIs, and then to automate the scoring and then tie that into pipelines. So that's really what today is. So kind of the challenge that we started seeing is, people are doing this, right? They have a pipeline. And, I actually, just a way of background, I long time was in the consulting world for performance engineering and performance test and test frameworks. So we typically did a build, deployed it. We ran some sort of test, but then there was a process of reviewing all those results, correlating system behavior to the transactions, maybe looking at logs. And so that effort was typically manual, right? Looking at stuff, or maybe it was given to another team to do the testing separate from the dev team. So that, took time to do that, to decide this particular build was good to go. And so we started doing functional testing to automate the functionality, and that's been in place. You can check, error rates and unit tests and functional, some sort of functional test or Selenium test even. But looking at the performance data was, it's not easy. There's a variety of tools, there's different monitoring tools. So how do we take all this data? Not everyone's a performance expert to look at this stuff. So, and then there's just a lot of data trying to tie it all together. So this is the challenge that's kind of driving the things I want to talk about today. Just, how do we deal with all this data? How can we automate it? And so at a high level, and this just, you can see that we want to put these SLOs and SLIs in files, and we want to integrate it into whatever tool you guys use, right? Whether it's a commercial tool, you can see some of the logos on the top, probably recognize some of them, or, open source tools, or even homegrown scripts that may do something. But the idea is that we want to define our service level indicators and objectives, and they kind of fall in different categories. So it could be, errors and availability, availability of a service that you're connecting to, for example, looking at code exceptions. Resource utilization obviously is a big thing too, whether it's a cost or whether there's more database connections or maybe service calls on build to build. And then also looking at, network saturation, throughput, that kind of infrastructure resources. But then, some of the value that you might already be doing are those key business transactions, making sure that those response times are in check, especially if it's an API. You want to make sure that that's, not going up by a couple hundred milliseconds, that then in turn affects a business application. So the idea conceptually is that we want to read these specs, go out and get our data in an automated way, calculate some sort of score on against the objectives. And then if we incorporate that into our pipeline, we can then, give a pass, warning, or fail, communicate that to the teams that we want to do, and then, either make a manual decision to do that, or ideally an automated decision to approve this pipeline to deploy the code into a next environment, or probably stop an environment, or take this data to drive a remediation action. And also we've seen this, I didn't put it on here, but there's a lot of, you saw me, the chaos testing tool. So this concept of being able to run experiments, and if you've ever done chaos testing, it's a series of experiments or tests that go against a hypothesis. So if you can have your hypothesis in your SLO in a declarative way that's codified, then you can automate a series of chaos testing too, to tell you, some answers and do that analysis for you. So I think that these are kind of the benefits if we could do such a thing. So your choices are, you could homegrown build such a thing, or you could, look at open source tools to maybe do that. So this project here, and here's the website, and it's pronounced Keptn, Keptn. So this is something that Dynatrace has been leading the charge on for the last 2 years, and has been moving through the CNCF. And we were at KubeCon. You might have heard us talking in the beginning. So it's really, starting with, some of the expertise we have around observability, but bringing it out. And we'll get, we're not going to draw the details of this, but definitely check out this, because it definitely does more than what I'm going to show today. I'm really focusing on the SLO kind of aspect of what kind of came out of this. And I'm just going to walk you through the concepts. And then when you see the demo, you'll understand the terms and map it to kind of what I'm going to show you. So the idea, as you saw before, it's like having a specification or actually the picture actually says service level indicator. So what we're trying to do is get data from some tool, right? Whether that's your source could be Prometheus metrics, or if you have, if you're using a commercial product like a Dynatrace, this data is in there. All this time series data is in tools now. And so the idea is to define an objective in a declarative way, something like, pass warning on like a threshold, or I don't have this on the chart, but the idea also is build to build to build. So as long as I think actually that little plus 10% is actually representing that concept. As long as this response time is within plus or minus 10% of my last 5 good builds, then that could also be a criteria for saying it's good to go. So, but then the idea is you take all of these individual indicators and give a target score. So you could say, I pass, and that's kind of what the scenario is. So build number 1 is, I have my definition, I run my build, I collect my data. Here is, as an example of the data that you got, and everything is in a green category. So I get 100% score. So this build is good, passes all my criteria. So now build number 2 comes along, and it's violating a couple of the indicator objectives. So it's more of a warning score. And then another scenario is, I have an error rate failure that's just too much in combination with a warning that this build's going to not be good. So then I would want to go back to a build 4. So this is really the concept of just build to build comparisons, and so that we can do that in an automated way, but then also do that with an overall score. So I'm going to get into the details of that, but I really love to see if anyone's tried. I don't know if this forum allows us to kind of have interactive chatting, but love to hear your thoughts on, if you've tried to do something like this yourself. Have you seen other tools that do something like this? Because this is where, it's not, it's kind of a logical thing. So it's hopefully it makes sense. And when you see how we tried to implement it with this open source tool, love to hear your feedback on that too. So what I'm going to demo next, and cross my fingers, everything will go as planned. But what I'm going to show you here is using these SLO and SLO files defined in this project captain. And then we're going to configure that within a GitHub Actions pipeline, where it's going to kick off this valuation and make that decision on the pass-fail score. And then also part of the project captain is a way to visualize these build-to-builds that I kind of showed on that previous screen. So really, the concept should map to a demo. So let me start with the demo. So, and I'm gonna kind of show a couple different examples, and I'll kind of watch the time because I will go, be able to answer questions or kind of cover things. But I'll try to walk through the straightforward demos. So just so I'm in a, so let me just do one thing first, but just to show you, so the captain project, if you go there, is this open source project. It's around lifecycle orchestration, and and I won't get into all the details, but what it's doing is there's basically a control plane that's executing sequences of tasks, and then you have services that are listening for those events, and I'll kind of show you what those look like. But then ultimately, this is more the output. So we want to then visualize something where I have these service level indicators like response time, memory checks, and then as I was showing you, these are my values, this is my score. And as I'm looking at this heat map here, if I click on the last build, everything was looking good. So this is where we're gonna reverse engineer back from this to see how the heck did I get this thing, and that'll make sense. So this is really what you want is like as you're doing build to build, to kind of trend out, either in a heat map kind of format, or you could look at individual score, individual metrics and see how it's trending build over build. So that's the idea of being able to visualize, these metrics, build to build, and then you could get all the details of it. So let's see where this data came from. So I can share all these hyperlinks. You can probably see my screen to see where they're coming from. But where this captain and project stores this information is in your repo, and it separates the objective, or the SLO. I'll just zoom in a bit, and you can see there's a declarative file that lays out each individual service level indicator, and then there's attributes to it, like here's my passing criteria for response time. It needs to be less than 1,000 milliseconds. This one has also had a fixed threshold too. And then there's other things in here where by default, it weights all of each indicator equally. So if there's 5 SLIs, everyone counts as 20% of the total score, but you could skew, or weight a metric like this one here. My error rate, I wanted to count a little heavier in the calculation. Or you could say this SLI is a key SLI. So if this SLI fails its criteria, then automatically, regardless of the total score, the whole thing fails. So those are some options you have to weight it, or say it's a key indicator. Or if I think there's a couple and then at the very end, and some of them you can say, I just want to gather the data. I don't even want to calculate it. So if all these are basically blank, then you're just saying collect the data. I don't actually have a criteria. In this case, just get it for me. And then at the end, this is your total score that you're trying to achieve. So this is what it declaratively looks like. So this YAML structure would live in your repo with your code. And then as that SLO evaluation service wakes up, it reads this criteria and it combines that with the other important piece. So in that case, I'm going to demo Dynatrace being the source of the SLIs. So now each SLI has a separate definition, and this definition can be shared across different services so that this doesn't have to get duplicated. So an error rate is the SLI name that then you saw in the other file. And then depending on the tool, this is a syntax that's specific to Dynatrace to say how to pull out this metric. So there in Dynatrace, there are built-in metrics, and you can basically have a whereby clause. That's kind of what this entity selector is, so we can pull out data based on specific instances or based on tags, etc. So I won't bother with all these variations, but then imagine if this was Prometheus, then there would be a Prometheus query behind it. So the open source project has a couple of different efforts to build we call them service level indicator providers. So then you and your implementation can say, hey, I use Prometheus, I don't use Dynatrace, or hey, I use Datadog, I want to use Datadog. So then you can drive the framework, and that's the whole power of it, regardless of the tool. So you get the SLI from whatever tool you use, and then you have your SLO, which is more of an abstraction of the metric that you want to go after. And then it rolls up into that score. Okay, so what I'm going to do just for one demo, I'll demo it without the pipeline first. And so let me just clear my screen. So with this project, there's also a command line tool that can basically invoke a pipeline, or we call them sequences. So let's say in this case, it's saying, hey, I want to do an evaluation sequence for this project, service, and stage. So this hierarchy is just how things get organized in Captain, where it's project, service, stage. Project can have many services, and then a stage represents like a logical environment. So you can have that way it supports a multi-stage world. So if I go back to my cloud automation environment, I'm kicking off. Oh, it happened so quick. Let me do it again. So it goes fast in this case because there's really nothing else other than doing the evaluation. So let's just do it real time. So you can see here this sequence. And so just to kind of show you how it does things, behind the scenes, there is cloud events that are driving across this control plane. So in this case, I triggered this evaluation to take place. And then this evaluation step started. So then within my sequence, I have an evaluation step. So now the evaluation step got triggered, and you can see some metadata around what to evaluate. And then it starts the service to go get my individual SLI. So now it's saying, hey, SLI provider, go gather these particular metrics, which again, this is the high level definition. So then it goes and looks in that config file to actually get the definition and then pulls it out. And then that's where we get it visualized. So I'll click on here. This brings me back to that graphic to pulling out the real-time metrics here. And so now you can see, it's kind of, I'll zoom in just a touch if you can see that, but then it calculated the score. So just to show you a real quick demo on the fly, what I can do is in my SLO definition, let's just force it to fail. So like, let's say, so we know that the, what's one here? So this response time, is like around a second. So if we were just to alter this config, edit it on the fly, let's just say the 95 percentile's got to be less than 1 millisecond, and let's see what happens. Run it again. Boom. Go back here. It happens so quick. It should fail. Boom. This is my demo on the fly. Please work. Go. Hang on. Let me just make sure my sequence started here. Let's do it again. It may have not. I may have triggered the sequence before it grabbed the update. So let's just see. Okay, here we go. So now it's running. Okay, go. So see, this SLI is going to the Dynatrace service. And so that's where it's triggering the started event. It now completed. And so now in the raw results, this is where you can see the values it got. So each individual score got evaluated, boom, boom, boom. Oh, I see the value. I think I typed 1. So it's, I think I still edited the wrong one, but anyway, so it looks like it passed. I just probably edited the wrong one. But what you can see is, but that's the idea. So now let me wire it into, so let me actually show you one more thing. So this is unique to Dynatrace. So editing all those little files may be, hard to know and control it. So one of the features of within what they did within, and we did an integration specifically for Dynatrace, So you don't have to worry about Dynatrace, but but I'll show you where we have synchronized a dashboard that contains all of these definitions with those SLI files. So by having a dashboard, where we're looking at those same metrics, let's just say 95, but response time, these are my response times. And if you look at in the tile, that definition of my response time needs to be greater or less than whatever, right? These are my throughput metrics, boom, boom, boom. This is my memory requirements. So, and then up here, this is my total target. So actually, this will be a better demo. So if I switch this to the paths, this just for fun, I'm going to edit. The paths has to be, 200. I don't want. Yeah, let's do that. You know what? Let me get a better one that's more accurate here. Passes less than 1. Done. Okay. So now by updating this dashboard, and now if I go back to my project, let's see if I updated it properly here. It synchronizes it back to my GitHub file. Yeah, man. There's like a process. This is the live demo. Classic. So let me just, am I? Yeah, I'm in the right place. Well, for sake of that updating this dashboard here will update, it will synchronize with these files. And I'm just trying to see if so what should happen here is my commit history should kick in. Just, I don't know why, classic demo here, come on. So when that is synchronized, then that's one way to manage it. So I'm basically can visualize and see my data. My SLI files are here. They get synchronized with my GitHub repository. And then that's another way to kind of manage these individual, settings. So then I can now do that. And so let me just, for sake of just moving on to the next phase of a little demo here, how can we tie this into our pipeline? So now we want to integrate this. So what I wrote another project that will basically containerize the invocation of this. So when you saw me do this little command, like trigger the SLI, right, and then get the results, I've encapsulated that within a Docker container. So within this container, it's grabbing this command line. Oh, I'm in the wrong one. In the command line tool. Sorry, I'm in the wrong project. So Captain has a multiple repos as an aside. We have a sandbox, there's a contribution, and then there's core Captain. So within this this sandbox project, people can contribute and put things in there. So here we are. So within this project, what I'm doing is automating the CLI command by sticking the CLI inside of a Docker container. And so within this Docker file, here you go, this is what I was trying to show you. So it downloads the CLI, and now it's inside of here. And then as part of this Docker container, I have a couple of scripts that it will run, like this SLO validation. So what will happen is it basically sets up the required parameters for your project, service, and stage. It can do there's different options for timeframes and starting and stopping. And then basically it's going to authorize the command line tool with your token that's stored, you'll see in GitHub. And then it will invoke that command we just saw, Captain trigger evaluation, blah, blah, blah. And then what it's doing is waiting, because it's asynchronous, as you saw. So you can trigger, do the evaluation, but you need to wait for it to be complete. So this is just staying in a loop, calling the API to say, hey, are you done yet? Are you done yet? Are you done yet? And then it's pulling out your score and result. And then there's a little bit of logic down here that you can control, like, do I want to pass on warning, fail on warning, always pass, ignore the result? And then this has logic to either, exit one out of the script or not. So when we tie that now into a GitHub action, I'll kind of show you that now. So I have in my repo, and we'll run this now. I have it in a slightly different folder here. I have it in this project here. So what actually, I'll make these, this one actually I made private for some reason, but I'll make these public. So what we have now, if you've not seen GitHub Actions before, there's look to me similar to Jenkins files. So, or if you're on JFrog, it's like a JFrog pipeline, similar. So this is basically now setting up the execution of that Dockerized task. So I've built my environment variables, as you saw, it's this project. Here's my time frame. And then now I'm basically saying, hey, use that Dockerized container that has the command line CLI, pass in all this stuff, and then run that SLO validation. So it's a really simple demo. So now if we go into GitHub Actions, so if you've never seen this, built into GitHub is this action. So now here I can just manually invoke it. So I'll do that. And we'll watch it run. And so what, again, so now just to kind of loop back to the story, what this is going to do is basically invoke that Dockerized step, who is going to invoke the command line tool to run the evaluation. So here it's just outputting, hey, this is all the stuff you're doing. And you can see here, it also kind of dynamically built up the job that I ran here in GitHub. And then there's just some verbose output because I had the debug flag on. And then you can see here, hey, I'm going to run this command now. And then, whoop, scroll too quick. And then you can see the output of that command as it's like loop number 1, I'm waiting for results. Number 2, I'm waiting for results, waiting. Number 3, oh, I got my results. Here's that big cloud event that you saw, right? With all the output, blah, 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 blah. And then at the end, it's saying, okay, my evaluation was ignore the result. I'm going to go ahead and pass it. And oh, by the way, you got a 100% score anyway. So it's just going to proceed. So if we go back to this guy and refresh, what we should see a little different now is actually, if we go back to the sequence, what's in here is when you pass in, you could pass in labels. So now you can see this was executed by GitHub. This is the run ID. And then because you can pass in that metadata as a label, if I click on that, that'll jump back to the specific job that did it, which is kind of handy. Where when you look at these ones, when I was running it, there was no labels. This one was run by GitHub. So if I go back to this guy and just to show you now, just a slightly, right. So that's basically that demo. All right. So that's sort of kind of showing you how you could do it just for sake of time. So this is where you could alter your SLOs. You can alter the behavior of that individual workflow step to say, I want to fail the job if there's a warning of the SLO. So then this job would die, right? Or you can proceed. And then you can put in the output as you saw, links back, and that's the whole idea of gluing things together. Okay, so demo number 2. So let me just move on, and then I can answer some questions too, if there's some. But let me just kind of show you just kind of the next thing I wanted to show you guys. So back to the ducks. So if you're paying attention to the ducks, again, I don't know why I had ducks, but what another thing around automation is also all this. So some of the config you saw with those dashboards, and that again, it's kind of work with a single dashboard and a single service. You can do some of that manual stuff I was doing, but you really need to scale it out and give teams the ability to kind of do this themselves. So we're trying to do this, orchestrate and keep people within that's the little duck analogy to do monitoring configuration also in a GitOps way. So this is also a practice that we're seeing. So that, here's an example as an SRE. I want to have all my SLOs in my project. So now, in addition to the SLOs themselves, I want to do this, and define it as configuration. So the configuration, so you saw like I had a dashboard that had the config, and I didn't want to hand edit the dashboard. I want configuration that creates the dashboard, so then I can manage the dashboard changes as code. That's the idea. So whether it's a dashboard or an alert or other SLOs. And so another open source project we've done. So so what I'm showing you is a specific management of the Dynatrace config, but you can see the approach that we did. And we also, I don't have it set up today. We've also done a Terraform version to do this as well. But the idea is that I store all of this config with my app code. I can run the applying of the config in my pipeline. And then now whatever tool I have, I can see that solution. So kind of the demo I'm going to do is going to show you some of this config in the repo. We got another GitHub pipeline that runs this thing. And now we've configured the monitoring tool. So these are some links to these open source projects. So you can see all the code that I'm doing. So let's show you that. So I'm going to do this in my editor because it's probably a little easier for me anyway. So let me just get this out of the way. So the way we store these little files is in a structure. So Monaco stands for monitoring as code. So the idea is you can have one-to-many projects that are then made up of different things that you want to manage as code. So like I said, if you use Terraform, this paradigm will make a lot of sense. So for example, service level objectives, I may have I may have a project that has, and just made up these numbers, service level 1, 2, 3. And then, so I have a configuration that's all using the same template file. And then the only difference is I'm just changing the name. So then the JSON file is the structure in our case, for how the Dynatrace API needs to receive the request to say, hey, make me an SLO definition. So don't worry about all the details of that, other than you can see the name is templatized. In the case of the dashboard, same concept. I may have one dashboard as a template, and then I have 3 different instances of the dashboard, and the only difference is the name change. And then the JSON file you can see is at the top is templatized. So if I want to run this thing, there is also a command line tool that runs, grabs this data, and what drives it is a config file that says, hey, what's your environment URL and what's your token? So if I was to manually run this, I'll just show you that real quick. So the command line tool is Monaco, and now it's saying, hey, deploy using my environment's config, and just basically apply everything in these projects. And I'll just kind of demo it here, and then we can see it run from the pipeline, which will just do the same thing. So here you can see it's parsing these files, looking for these configs, and then going ahead and applying them. So on the Dynatrace side, if we go back to Dynatrace land, and I go to my dashboards, I probably should have shown you that the dashboards didn't exist, but what it did was made these 3 dashboards, boom, boom, boom. In fact, I'll delete them and then I'll re-add them, then you can see them. So here we can say, these are my SLOs, and then these are my dashboards. And what I have in this config is creating my dashboards, applying my config, release validation dashboard, error rate. There we go. Okay. So now with that being done, I'm just going to delete them. So I have there's a way you can say, hey, what are the configs that I want to delete? It's just another feature of the CLI tool. So let me just rerun this. And what it'll do is it'll clear out these files. So if we go back to here, we can see those dashboards are gone. So this is where the automation is. So if you can store your config and your definitions and manage that as code, there's no one hand editing all this config of some tool. So then you have the full GitOps history of who did what. You can control it. You can manage the tokens, so no one can come in here and edit anything without doing it through this prescriptive way. So going back to my GitHub demo, kind of show you the other file, which is the Monaco. So similarly, we took that CLI tool, stuck it into a container, versioned it, and then it expects certain parameters, and then through a so then when we run the command line tool, it's basically that same thing you saw me run at the command line. And so now if I go into actions, let's trigger this guy and run it. So just imagine, so I'm doing this very atomically where I'm just running this one little thing, but that step could be inside of other steps. So this, I'm showing Azure, it's not Azure, but I'm showing GitHub, but the same technique could be in Jenkins. It could be in fact, I've done work with JFrog, who's actually on the line, where we were doing the same thing. So it's really around if a downstream tool has an API, that's how you can glue things together. But then you want to do it in a way that's easy for a dev team to consume, and then you want to have control over what these packages do. So you can see when that job ran, that's the same output that you saw before. If I go back to my dashboards, I hit refresh, knock on wood, boom, there's my 3 dashboards again, 1, 2, 3. So they got re-added. So you can see the pipeline, grab the config as code, wrappered it, called the API, built all this thing. Now we can see it. So I think between the combination of those two, that's really what I wanted to show you today. Just ways of automating things, ways of having declarative code for config, as well as declarative code that for service level objectives and indicators. And then you can wrapper it through this automation and then we'll put it inside of pipeline code. So we do see people using this a lot. So it's definitely, as people are adopting Kubernetes and they need to manage all of this stuff, in that stream of ducks, as I showed earlier today. So the idea is that we need to have these tools, give them to dev teams, but to have it in sync with the operations team. So they still have to define tagging standards, naming conventions and all that good stuff, access controls, so that things are done in concert with the standards and whatever policies that may exist. So that was kind of a lot there, Steve. I can kind of just pause. I don't know, I'm looking at the clock just for sake of time. I mean, if there was any open questions, maybe there's a couple in the chat window here, but happy to take any reaction one way or the other about kind of what you saw.
I think this is really cool. Like, this is the first time I've seen Captain, I think, in a while. And I've never
and I guess I'll
seen
separate Captain from, so I guess you saw me do cloud automation right there. So we do have, right. So what's happened with Dynatrace is the open source project is there, available, runs on multiple Kubernetes environments. And that's out there. We're building this community, especially with the CNCF, it's really grown a lot. But then Dynatrace has now made a SaaS version, or powered by Captain, if you will, as part of Dynatrace. So now Dynatrace, if you want Dynatrace to run your cloud automation, control plane, then that's what you're seeing here. So this is where some customers don't want to manage it, and this gives them an option to do that.
So is that sort of like Captain as a service? In other words?
Yeah, it is Captain.
Or are you guys extending? Are you guys extending Captain in specific ways?
We are, well, one way we're doing things is single sign-on. So when I log into
like
this,
enterprise stuff, it's
an enterprise. There's also, again, when it's SaaS, it does high availability clusters. The open source standard, the open source one has like a Mongo database inside of itself. We've kind of separated that out and made that commercial kind of database. There's also, there's more on, again, I don't want to do too deep in the commercial side, but I mean, there's just a lot of things that we want to just integrate better, token management, roles, scope-based security for tokens. And a lot of those are driving from and then we usually push them into the open source world because we want those same features to be there, right? So we want the features, and so the Captain project is managed totally separate from how Dynatrace uses. There is a Captain team open source team, and they're separate from the commercial side, but the community is very active. So anyone that wants to learn about it, I had that one slide a second ago. These are the forums. There's also so as you get into the project, you can see community meetings. There's a YouTube channel. There's a very active Slack channel too, where we have a lot of I think so you have almost 1,000 people now in here. And so this is a very active channel. This fella, if CloudBees was one of your sponsors. So Oleg was one of the leaders in the CloudBees Jenkins, one more the Jenkins side. He worked for CloudBees, now he works actually for Dynatrace. So he's really championing our open source community and bringing a lot of maturity to how we run, to be able to go to the next level than CNCF. So to be in the CNCF, there's oversight board members, and really everything has to be promoting and supporting open source, between how the code gets built, and then when you do integrations, that you're really adopting the the open standards, like whether it's CD tools that are open source, load testing tools, chaos testing tools. So all of those things like Litmus, chaos, and Argo, and Prometheus, and all those things are all part of driving the innovation. So there's a lot of innovation that happens in Captain, and you can say there's a community. So definitely there's CNCF Guatemala. So really kind of growing and promoting and encouraging people to build integrations. So there's a dedicated integrations team, there's a core development team, as well as maintaining the documentation. So definitely it's a legit project for sure. And I think it's pushing, and you can read more about, because it's driven, the underpinnings are a control, declarative model, Git based, event driven. And then again, the SLO is one aspect that really makes that people tie into when it comes to the observability aspect. So yeah, you definitely reach out to me. Definitely, I'd say let's we can even do something within the your guys's world. We can make a little thread if people want to do it. We have like little times where people can whatever. So we can, happy to share more information on that. That's kind of why I was here, just sort of to share this and hopefully get feedback too. Like, hey, is this, what other alternatives are people trying? Are people building homegrown solutions? Are they, are there other open source projects that kind of try to solve this problem? Because it really goes back to, those principles of the DevOps handbook and what that we see, that's what Google really is, the ones that made Kubernetes put that out there and really driving a lot of stuff that we all work on. But thank you for the time. I mean, thanks for the audience, and hopefully feel free to reach out to me, and hopefully I'll try to come to more of your meetings and listen to all the other great presentation you guys have, because we're definitely all learning every day. I know for sure I am.
It was great. Sorry, I had a little bit of chaos because I lost my camera, and then I had to scramble to get everything hooked up again. But I like that a lot. I think there's some very cool pieces in there that address areas of what I'm looking at the value stream, like the middle parts where it gets complicated, where folks slow down during deployments and validating that the things that they're doing aren't broken, or that they're not degrading performance too much. And then kind of the last mile, like once you deploy to production or whatever your environments are, like how do you make sure that you haven't messed anything up and things aren't actually worse?
Right. Well, and that's where we've done some things like, I've done some use cases where we've done stuff with, incident management tools. So being able to make that request on the fly, like, hey, I've got a ticket and I think I bounced the server and it should have resolved it, but let me quickly do an on-demand service level verification, because it's just an API call now. and now you can get immediate results and say, boom, it looks good, right? So you could also automate that within any delivery script. So the source of the data doesn't have to be system metrics. It could be business metrics too. So if you're doing a canary release, for example, and you want to like, all right, let's just make sure that the user health is good, right? And then if that looks good, now I can scale it out to, a broader audience. Or we also, a lot of use cases, beyond just service levels is, then driving, playbooks, so if I want to, I'm doing feature flag management, right? So there really isn't a deployment, but it's I turned on this feature flag. What happened? Did it look good? Did it do bad? Do I need to flip that thing off automatically? So really driving, that's kind of that orchestration that we're pushing and trying to see how we can push it to the next level of like informing it from the observability, make your automated playbook, send all the notifications out to the Slack channels and Microsoft Teams or whatever they're using, update your Jira tickets, your incident management tickets, run the automatic playbook, validate that it did place, automatically update all the tickets. So if we can really scale up, and it's really that crawl, walk, run is what I've seen, is where automating a lot of that analysis. So if every time I'm quickly just look at this log and do this and this and this, can I put that in a little utility script and run that as my first check? Then if I'm just bouncing a server and we need to check it. So it's really like taking the things that you do over and over, automating them, putting them together. But then once you have a bunch of scripts, then you're like, hey, I need to do it in a unified way. Then that kind of then drives either some sort of platform, whether it's you buy the whole platform. But the thing is, in reality, big enterprises don't have one tool, one pipeline tool, or scripts or architecture. So that's where this event-driven concept and orchestrating things through events and letting the services subscribe to events and react to events makes a lot of sense. So there's another group called the CDF. I don't know if you guys have heard of them, but it's the Continuous Delivery Foundation. It's another open source body trying to get people to weigh in, and that's where they got a special interest group that focuses on the eventing standard. So again, if we can say deployment started, finished, ended, test started, finished, ended, if we can all agree to the types of things that happen, which is really your value chain stuff in a way, Steve. But if you can agree to those, not necessarily, but there's activities that take place that are all the same, right? Deploy it, build it, test it, whatever. If we can agree to an event definition and the event types and how things would do that handshake, then they could be implemented in a variety of tools. So we see that from stuff like, you can see AWS is doing something that with Event Bridge. So if you see that, if you ever Google Event Bridge, they have something where they're integrating in, providers and consumers. And then now both AWS and Azure have a lot of stuff with logic apps. So if you see that, they're reacting to an event or a Lambda function to react to an event, translate it, parse it, send it on to, the next stage. It's kind of, we used to call it middleware, a couple of years ago, but now it's, this orchestrated event buses. So Captain is, in that category of trying to do that. And then actually some commercial tools are also, looking for that same model too. So because we don't want to build all these point-to-point solutions, right? You don't want to, because that's expensive to maintain, and then it becomes very rigid if I want to change my tooling. So, I want to go from, I don't know, make a tool up, I want to go from tool A to tool B. But if everything's so hardwired and I have in hundreds of pipeline Jenkins files, it's a nightmare to change anything. And that's another motivator. I think one of our strategists calls it next generation, the next legacy code is you're going to be your pipeline code. And that's the idea of this too, is if I can loosely couple things through an eventing paradigm, then I can theoretically swap out things easier and say, just do the test, Mr. Test tool. I don't have to hardwire that direct linkage. So, and that's what you saw, I think, earlier with the SLOs, like, here's my SLO. I don't care where it came from. It's just a response time. So the provider of that response time changes from Prometheus to Datadog. It won't break my definitions. So
that's really cool. Yeah, I like that. I like that aspect of it. Yeah, I gotta go dig into this because
Yeah, dig in and yeah, see the
seems
community.
relevant to my
There's
interests.
a lot there. Yeah, for sure.
All right, Rob. Well, I'll let you off the hook.
Yeah, thanks.
Thanks
No
so
worries,
much.
yeah.
Really appreciate it. And for anyone else who's sticking around for the next little while, join us and gather.
All right. Yeah. And again, I joined your Toronto DevOps Slack, so I'll be following you guys, and feel free to reach out to me there too.
Really appreciate it. Thanks.
Yeah, no problem. All right, guys. Well, thank you. I'll just